So at that moment the salt bridge plays an important function. So just look at the board how it plays. As you know that the salt bridge consists of an inert electrolyte. So that means it has the potassium ions and it has the chloride ions. As I told you, there is excess positive charge which is just deposited in beaker 1 and there is excess negative charge which is surrounding the copper rod in the beaker 2. So this is just preventing the zinc atom to lose electron, and this is just preventing the electrons to come to beaker 2, or you can say they are just preventing the reduction of the copper ion. So if the zinc atom will not get oxidized and if the copper ion will not get reduced, that means the chemical reaction will stop. That means the production of electric energy will stop, or you can say ultimately the cell is going to stop working, right. So at that moment salt bridge, what it do actually, it just to make the cell keep on working, it just neutralize the excess positive charge in beaker 1 and simultaneously it neutralize the excess negative charge in beaker 2. So just see how what it do actually, it has the inert electrolyte. So what it do, it just pass the oppositely charged ions like chloride ions. Chloride ions are passed from the salt bridge into the beaker 1 to just neutralize the excess positive charge, right. So that you can say the concentration of Zn2 positive just falls and the zinc keep on oxidizing. That means zincs keep on losing electrons, right, and these electrons keep on moving to this beaker 2. Now what salt bridge do actually for beaker 2? So it also neutralizes the excess negative charge by passing the K ions into the solution. That means the positively charged ions. So these positively charged ions just neutralize the excess negative charge due to the sulfate ions, and they will, so that means they will not prevent the reduction to occur, they will not repel the incoming electrons, and the reaction will keep on taking place and the electric energy will keep on producing, and that means the cell will keep on working. So this is actually a electrochemical cell. I think you got it in a correct manner. Again in a short recap I'll just repeat the function of salt bridge. What you need to write, just write in your copy as I am dictating. So the function of salt bridge plays an important function. The first function is that it completes the circuit by connecting the solutions of two beakers, right. Second is that it you can say it maintains the neutrality of the two solutions in the beaker. How now it maintains the neutrality? You will write that we get to see this kind of equilibrium existing in this, and we need to see this kind of equilibrium existing in beaker 2. Right. So what happens with passage of time, the zinc ion concentration increase, which prevents further oxidation of zinc atom. And similarly in this, due to more reduction of the copper, due to more formation of this copper, this rod gets surrounded by the excess sulfate ions. So what happens? What adverse effect they have? So the adverse effect is that they will just prevent the zinc atom to get oxidized, more zinc atom to get oxidized, and they will just prevent the repel the incoming electrons and just prevent the copper ions to get reduced, and the reaction will stop. So in that case it just plays an important role. What it do, it just pass its oppositely charged ions, that means the excess negative charge into the beaker 1 so that it can neutralize the excess positive charge, and at the same time it just pass the positively charged ion into beaker 2 to neutralize the excess negative charge, so that the oxidation and reduction keep on taking place, and there is no, you can say, the loss of that means the chemical reactions still keep on taking place and the electric energy keep on producing. So this is how you are going to just explain the electrochemical cell. So whenever you get to write something about electrochemical cell, just write its definition first, that it is a device which converts this energy into this energy, right. So that means at the cost of chemical reactions the electric energy is produced. What is the principle? The principle is the indirect redox reaction, right, and then just draw the figure, then just as I told you point wise. So if you write the answer point wise, it will be easier for the examiner to understand, right. So just write that when the switch is off we get to see this, when the switch is on what we get to see in beaker 1, what we get to see in beaker 2, and the overall, what is the overall reaction, and then what is the salt bridge, right. So this is how you are going to attempt. Now you should know that the beaker in which the oxidation occur, right, is called as oxidation half cell, as you can see, the cell is divided into two halves, right? So the cell in which the oxidation occur is called as oxidation half cell, and in which the reduction occur, as you saw that it occurs in beaker 2, so it is called as reduction half cell. So actually a complete cell is a combination of the oxidation half cell and the reduction half cell. Second thing what you need to remember is that the one which get oxidized act as anode, and the one which gets reduced act as cathode, right? So and what is the movement of electrons? You know that the movement of electron is from anode to cathode. I'll write here the movement of, I'll just sum here that the movement of electrons is from anode to cathode. Anode act as negative terminal and cathode act as positive terminal. So that means in internal circuit the current is flowing from anode to cathode, but conventionally in external circuit it is just flowing from cathode to anode. So that means electrons are flowing from anode to cathode, but conventionally in external circuit the electrons or you can say electric current is flowing from cathode to anode. So this is how we have just come to the conclusion that what is the oxidation half cell, or what terminal it actually act, the anode and the cathode, and what charges they have got, and what is the direction of, you can say, the current, or you can say what is the direction of the flow of the electrons. Now there is a method to represent an electrochemical cell, like if you get a 3 marks or a 5 marks, or I can say if you get a long answer you need to attempt like it, but sometimes what you get, you just have that this and this beaker is present with the constituents present, which rod, which solution, which rod, which solution, and like the examiner asks you that how you will represent an electrochemical cell in a mathematical expression. So there is a mathematical expression in which like how we just express this electrochemical cell. So just look at the board how you have to express it. I'll rub this side. See, if somebody asks you to just represent the electrochemical cell, what you need to write? First you write the oxidation reactions and then the reduction reactions. So that means, you know, oxidation means there was zinc atom slash which got converted into the Zn2 positive, right? So this act as in it this constitute the oxidation half cell and it constitute the anode. So write like this, right? This beaker is just separated from this beaker by salt bridge, and salt bridge is indicated by the two parallel lines, right? And what you get to see in that, here the reduction occurs, that means copper ion gets converted into the copper. So this is so simple. What you need to write? You need to write what it was initially and what after the oxidation it became, right? And similarly what it was initially in beaker 2 and what after the reduction it occurs, right? And this is the reduction half cell, and it acts as cathode, right? And the electrons just move from this side to this side. So this is how you're going to represent the electrochemical cell. Do write that this two lines indicates the salt bridge. So this is how you're going to represent the electrochemical cell. So that means if you're provided with any couple, that means any atoms which was undergoing the oxidation and the reduction. So what you get right, you have to write this side the oxidation one and this side the reduction one, separated by the two parallel lines which indicate the salt bridge, and indicating this arrow, this indicating the flow of the direction of the electrons. And do not forget to write the anode and the cathode one, right? So this is how you are just going to attempt the question when you get on the basis of electrochemical cell. But this is not actually limited to this is not only limited to the electrochemical cell. Actually we have a certain you can say the parameters which are used in electrochemical cell, like electrode potential, that we'll be taking up now. But before we start, you should be familiar what actually this whole process was, right? So this is how you can say that you are going to attempt the question when you will get in your exam paper.